Oops, wrong page. All right. Good morning. We are on CO43. I can use probability to calculate the odds of an event. So we're still working with those probabilities. We have some definitions to fill in. First one is the probability of an event. It compares successful outcomes to total outcomes. This is a fraction. When you are comparing successful outcomes to total outcomes, you're putting that fraction bar in between there. The odds of an event compares our successful outcomes to unsuccessful outcomes. This is a ratio. So successful outcomes to unsuccessful outcomes is a ratio. Probability successful outcomes to total outcomes is a fraction. So we get different answers for probability versus the odds. So we use the odds if you're going to go to a casino and play Blackjack. You're going to use the odds, the probability of getting something, and then you want to know what are the odds that that's actually going to be what I get. So, Blackjack is a card game. It's a great game of probability and odds. So let's look at if we have a standard 52 card deck. A regular deck of cards has 52 cards in it. We're going to write the probability as a fraction and a percentage. So we should know how to do fractions and percentages. We can find the percent from a fraction. And then we're going to also find what the odds of each event occurring is. So we're going to do both. We're going to do probability and odds. So what is the probability of choosing an odd numbered card? There are 20 odd numbered cards. What should I write for my probability? Remember, successful outcomes to total outcomes. There are 52 cards in the deck. There are 20 odd numbered cards. How should I write that fraction, Chase? We have probability of getting 20 odd numbers out of the total 52 cards. So this is my probability. Now it says write it as a fraction and a percentage. So what percentage would that be? Oh, first, am I going to accept that as our probability? Why not? We have to simplify. Okay, so the first thing you do is you figure out 20 out of 52, but then we have to simplify it to what, Andrea? 5/13. So probability, it's a fraction, so you always have to simplify fractions. Now I need to put what percentage that is. Izzy? 38%.
Actually, I think it's 39. Yeah, but then you round up from there's like 6 after the 4.
Oh, you only look at the very next place when you're rounding. So you look at that thousands place. If it's a 4, it stays the same. You don't care about the 10,000ths place. Am I done answering my question?
No.
Why not? Nope. I said fraction and percentage. I did my fraction and percent. I have to do a probability and I have to do the odds. Oh, it is so important that when we take a test, we pay attention to the directions. Because when we're doing 2 different things for the probability, it's so easy to forget that we also have to do the odds. But if you forget on the test, are you going to get that one right? No. So if it takes you to circle what you have to do, underline, make sure that you're doing what you have to do to remember to do all the parts. So I did my probability. Now I have to do my odds. What would I write to find the odds? Successful outcomes to unsuccessful outcomes. Maddie? How many odds are there? What would my successful? So there's 20 odds. So that would be my successful. We have 20 cards that we could choose from. How many would be unsuccessful?
20.
If there's 52 cards in my deck.
Oh, sorry. 32.
32. Am I done?
No.
Why not, Joseph?
Simplified.
What would it be simplified? What's my greatest common factor between 20 and 32?
Oh my gosh.
Molly, what can I divide out of both of them?
6 by 4.
Yeah, if I divide them both by 4, I can't get any simpler. Okay, is that making sense? Let's look at our next one.
But don't we need to get a percentage for the odds? No.
Write the probability as a fraction and a percentage and the odds. You can't get a percent if it's not a fraction. Odds are a ratio. You can't do percentage of a ratio. You can only do the percentage of the fraction. So now we need to find the probability and the odds of choosing a face card. So I don't forget, I'm going to write probability and I'm going to write odds. So we remember to do both. So probability of choosing a face card. Oh, look at that. He tells us how many face cards are in a standard deck of cards. Remember, probability is comparing successful outcomes to total outcomes. What would it be, Colin? 12 over 52. Because successful, there are 12 chances of getting that successful. 52 total. Am I done?
No.
Simplify. Go as low as you can go. 3/13. I can divide both the top and the bottom by 4.
What's 13?
Somebody was asking about 13 divided by 4.
Sorry.
Yeah, we're not doing that. We're dividing 52 by 4 to get 13.
Oh, sorry.
So we're dividing both of them by 4. So then we need our percentage. What percentage is 3/13? Charlotte? 23%. Now I need to do my odds. I wrote the odds down there so I wouldn't forget. How do I find the odds, Paul?
Alright, so 52 minus 4.
I'm sorry, say that again?
So because there's 12 base cards.
How would I set up my ratio?
Oh. 12.
So remember, odds in an event is successful outcomes. So it's 12. Our total number of outcomes is 52. So we want unsuccessful. So we want to subtract 12 from 52. 40. So you had the right thought. You were just doing the math wrong. Am I done?
No.
Why not? They're both even numbers. I know I can simplify that. What can I divide out of both 12 and 40? Sam?
4.
I can divide a 4 out. 12 divided by 4 is 3. 40 divided by 4 is 10. So the rest of this page, you should be able to do, always looking at what's the total outcome, what's the unsuccessful outcomes, depending on if you're doing a ratio or if you're doing the fraction. Let's look at our second page. Oh my, now we're actually at the casino playing that blackjack. Thank you to my friends who are staying calm and quiet and being respectful. So in the game of blackjack, you and the dealer are each given 2 cards. There's absolutely nothing wrong with playing blackjack. I play it at home with my kids. It's a card game. I don't go to the casino and I don't bet money on it. But you can play blackjack. We play poker all the time.
Yeah, penny poker.
Okay. So both of your cards and one of the dealers are face up. For each situation below, answer the question using probability as a fraction and percentage and the odds, just like on the page before. You need to do both probability and odds. And so answer should be in simplest form, like we were doing. Assume that you are using a new 52 card deck for each situation. And since one of the dealer's cards is unknown, it should be considered part of the 49 other unknown cards in the deck. So you know the 3 cards. So 52 minus the 3, there are 49 unknown cards. Make sense? So there's 52 cards in your deck, Joseph. Dealer deals you a card. Dealer deals himself a card. The card that the dealer deals you is flipped up. The card that the dealer deals himself is flipped up. Dealer is going to give you another card flipped up so you know what your 2 cards are. The last card the dealer keeps covered. So that last card that we don't know is a part of the unknown deck. So that we don't know what it is. So there are 3 cards that we know, 49 cards that we don't know. Okay, the purpose of blackjack is to get as close to 21 as possible without going over 21. That's called busting. You don't want to bust. If you get 22, you bust and the dealer wins. Okay? So no matter what, if you bust, the dealer wins. Each card has its numerical value. Face cards are worth 10 points. Aces can either be 1 or 11. So that's how we get 21 with 2 cards. You can have a face card and an ace. Face card's worth 10. That ace is worth 11, so that would be 21. So if you had a 4 and an ace, you could say that's 5 or 16. Sorry, a 4 and an ace would be 15. I had 5 in my head. So a 4 and an ace could be 5, or the 4 and the ace could be 15. You can decide. So if you take another card and you get a face card, you would want to count that ace as a 1. You can go back and forth to whatever works to try to get to 21 without busting. You are showing a queen and a 7. The dealer is showing a queen. What is the probability of drawing one more card and not busting? So if we have a queen and a 7, we're at 17. We need to think of how many cards there are to get to 21. So queen and a 7 is how many points? 17. So we could get an ace. How many aces are in a deck? 4. We could get a 2, because an ace would put us at 18. A 2 would put us at 19. There's 4 2s. A 3 would put us at 20. There's 4 3s in the deck still. So that puts us at 12. Or a 4 would put us at 21. There are 4 4s in the deck. So that's why there's a 16 right here. Because there are 16 cards that we can draw from that would give us a 20, up to 21 without going over 21. So you would want to pull an ace, a 2, a 3, or a 4. You really want to pull a 4 because that would put you at 21. Okay. So what is the probability of drawing one more card and not busting? So we have 16 possible to give us a successful outcome. So if we look at our probability, remember, successful outcomes are on top. What is our total possible outcomes? Chase? 49. Because remember, there are 49 other unknown cards. Is that in simplest form? Yes, it is. So what percentage? Remember, we want the fraction and the percent. So what percentage would that be? Caitlin? 33%. Now we need to find the odds. So remember, the odds are the successful outcomes. So how many successful outcomes could we have? 16. How many unsuccessful would there be? Joseph? 33. Can I simplify that? Okay, that's as simple as I can get. I can't divide the same number out of both sides. So my odds are 16 to 33. That's just my calculator, not my phone. It's all good.
If that were your phone, that would be a really bad noise.
Yes. Okay. Is that making sense?
Yes.
Do you want me to do one more?
Yes.
Okay, let's look at that next one. You are showing a 9 and a 9. The dealer is showing a 2. What is the probability of drawing one more card and not busting? So a 9 and a 9 is how many points? 18. So you could draw a 1, a 2, or a 3, right? So that's 4 1s. There are 4 2s and 4 3s, but why does he have 11 here?
Because the dealer's showing the 2.
The dealer is showing a 2, so there's only 3 2s left in your deck. So that's why there's an 11. So you have to pay attention to what cards are showing. It would have been 12, but since we already took one of those 2s, now it's only 11. So what's my probability? Is 11 out of 49. 11's a prime, and it doesn't go into 49, so I know it's simple. And it's what percent?
22%.
22%? Then I need to find my odds.
the odds would be 11 to 38.
I've got 11 is my successful, so now I want the unsuccessful. So 49 minus 11 is 38. Can't simplify that. 11 is a prime, and it doesn't go into 38. Okay? So I'm going to give us some time to work on this. Shh. Don't get overwhelmed by it. Just slow it down and look at what they're telling us and what we know about our probability and our odds. Remember, they are two different things. Probability is the successful over the total. The odds are the successful over the unsuccessful. So we're going to say goodbye to anybody that is watching this, and we hope you have a wonderful day.